So we have finished our work on the feature branch and we want to merge our changes into the main branch. But while we were working on the feature branch, a new commit is pushed to the main branch. And as we can see in this commit history, the two branches have diverged. In this case, when we ask Git to merge feature branch into the main branch, Git will create a new commit called here C6 in order to incorporate changes from feature as well as this commit free from the main branch. And then it will move the main branch pointer now pointing at C6 commit. But how does Git create this merge commit? Let's dive in. In order to create the merge commit C6, Git will consider the tip of the feature branch C5, the tip of the main branch C3, and also the first common commit between these two branches, which is C1 commit here. This commit is also called merge base. Now let's consider we have the following project which has only 4 files, 2 Python files and 2 text files. Now in order to understand how Git merge works, we need to take a look at the snapshots that we have saved for the 3 commits that we have C5, C3, and C1. So let's start with C1. So we're looking at the tree of this C1 commit. So just to remind everyone, a tree object is nothing but just a table of contents that maps file names such as chapter 1 to its version or to its blob ID or hash ID. So we have this mappings for C1, the merge base commit. And for the main branch, C3 commit, we have exactly the same tree, except that the mapping for chapter 1 has changed. Now we have a new version compared to the C1 commit. And similarly for C5 feature, we have changed the mapping for chapter 1 and chapter 2, so different versions. And we also have a new file. The README file is new in the feature branch. So here's the most important part. Based on the 3 snapshots, the 3 trees that we saw, Git needs to create a new tree before it can create the merge commit. So how does Git assign versions for each of the file names that we have? So the 2 Python files did not change in any of the branches, so Git will just use the same versions as before, no confusion here. And then for the new file in the feature branch, it's also quite straightforward because this mapping only exists in one of the branches, so Git will just use this version from the feature branch. So here I have the shortened versions of the tree for C1 commit, the merge base, as well as the main branch and the feature branch. And for chapter 2 file, Git will quickly see that the version is the same in the main branch and it has only been changed in the feature branch. This case is also quite simple. Git will just say, okay, you have only changed this file in the feature branch, so I'm going to use that version. So basically it will use the version from the feature branch. But how about chapter 1 file? If we take a look at these 2 trees, we see that both of the branches, feature and main, have changed this file. In this case, Git cannot use any of these versions because it doesn't know which one it needs to keep. Here Git will go one step further and it will inspect which lines have changed in the feature branch and which lines of this chapter 1 file has been changed in the main branch. In this video, we assume that both of the branches changed different lines in this file, so we have no merge conflict. In this case, that they have changed different lines, Git will create a new version. You can see this is a new blob ID. So a new version for chapter 1, which incorporates changes from both of the feature branch and the main branch. And then it will use this version for chapter 1 file. Now let's see this in action. So I've opened the project in my VS Code and here I have a terminal. So let's start with using git log --graph --all command to show you that the main branch and the feature branch have diverged. So here we see that we have these 3 commits in the feature branch, the green lines, and we have this red line and only 1 commit in the main after the divergence. And this commit is the merge base or the common ancestor. First, I'm going to show you the snapshot of our project in all of these 3 commits. So this ancestor commit, the feature branch, and the main branch to see what has been changed. I'm going to copy this ancestor or the merge base first. And I'm going to use the git checkout command, which basically with this command, you can check out, or you can go to a specific version. So we want to check out this version. You can ignore these messages. I just want to show you the files. So here we have the chapter 1 file, and you have this in chapter 1. And for chapter 2, you have 2 lines. The plot thickens is repeated here, and it's a very long line. All right, now I'm gonna switch to main branch and to show you what has been changed in the main branch. Now we are on the main branch. I can confirm this with using git-branch, and you see we are on the main branch. And here you see that this has been added to this file in the main branch. The rest is the same. Chapter 2 file seems to be also the same. So the only change in the latest commit of the main is these 2 lines. All right, now I'm going to switch to the feature branch and see what has changed there. You can see that when we switch to the branches, Git is updating the working directory, and you can see that these change. So here you see that there is this line that has changed. So the feature branch has also changed chapter 1 file, but on a different line, so different place. So remember, the main branch had added 2 lines here, but the feature branch has only updated or changed this line 2. It has also changed chapter 2. You can see that line 1 is removed, and then this previously long line has been separated over multiple lines. And we can also see a new file here, readme. So we have this new file in the feature branch. All right, so we know the changes. The main branch has only changed chapter 1 by adding some 2 lines to it, and the feature branch has a new file, readme, as well as changes to chapter 1 but in a different place, and also has changed chapter 2. So let's merge the feature branch into the main branch. For that, first we need to switch back to the main branch. So let's confirm which branch we are. So we are on the main branch, and we want to merge this feature branch. So for that, we will use git merge feature, and there we go. And now Git is using I think Vim editor, and here we can update the commit message if we want. I'm gonna leave it like that, but you can edit this. I'm gonna press shift to select double colon, and then WQ to save and exit, and here we are. So as explained in the slides, Git has to do this auto merging for this file chapter 1 because both of the main as well as the feature branch changed this file. But for the rest, for readme, it was easy because this was a new file, and also for chapter 2 file, only it was changed in the feature branch, so there is no confusion for Git. Let's first check out the history of the commits in the main. So we see that the main branch now is pointing at this commit, which is our merge commit, our new commit. And you can see that it has 2 parents. It has this add to list, this comes from the previous main, as well as the feature branch. We can verify this actually. Let's look at git cat file -p. I'm gonna look at this commit, so the main, so I can just do it using main, and here we're looking at the latest commit of the main. I just want to show you that it has 2 parents. So it has this parent starting with A6, which is this one, which comes from the main, and also the other parent F12 is basically the latest commit of the feature branch. All right, let me clear first. I'm gonna do git log --graph --all to have a better view. So here we see that we have merged. You can see that this new commit merge branch feature is our merge commit, and this is the feature. And if we go down, this was the tip of the main branch, and this was the ancestor branch. I'm gonna start from the tree of this snapshot, and then I will show the tree of the feature as well as the tree of the previous tip of the main, this one, and maybe also the common ancestor. So let's take a look. I'm gonna copy this previous tip of the main because I will need it. So I'm gonna clear. Now I'm gonna use git ls tree -recursive, and then I will use the head or the current main. And here is the tree that we have. So we have these files, and here we have the versions. Now let's check the tree for the feature branch. And here is the tree for the feature branch. I'm gonna do the same now for the previous tip of the main branch, the commit that I just copied. All right, so these two, this and this, are basically the parent commits of this commit. And here I'm showing the tree object or the table of contents. Now, the README is easy. So it's a new file and it definitely comes from the feature branch. We only had it here and you can see it has the same version. If you see this blob ID, it's the same as this one. For the Python files, the main and text utils, they're exactly the same in all the versions. So you can see both of the feature branch as well as the main branch had the same versions, and it's the same in our new commit. So that's also easy. Now for chapter 2, which was only changed in the feature branch, you can see that the version in the feature branch, this with this blob ID, is exactly the same. E7 D6 is exactly the same as in our merged commit. But how about chapter 1? If we look at the blob ID of chapter 1, we see that it is different than the one in the feature branch. This one, it is also different from the one in the previous tip of the main. The reason is that both of the feature and the main branch had changes to the same file, chapter 1. So Git had to create a completely new version with this blob ID and merge both of the changes into the same file. And that is why we have a different version. And Git could do this auto merging for chapter 1 file because our changes in these two branches happened in two different places. So if two branches did change the same lines or in the same places, then Git wouldn't know which one to choose, and it cannot do an auto merge, and it will throw a Git conflict. In the next video, we will see what a Git conflict mean and how we can easily resolve the conflicts. See you then.